guys, it's Carol here. Lesson 1.6, Parallel and Perpendicular Lines, Part 2. Essential questions. How do you write the equation for parallel and perpendicular lines? How do you graph parallel and perpendicular lines? That was Lily. He is quite tired. As a quick reminder, parallel lines. Lines in the same plane that never intersect. They have the same slope, but different y-intercepts. Perpendicular lines. Lines in the same plane that intersect at right angles. Slopes are negative reciprocals. For example, negative 2/3 and 3/2 are negative reciprocals. Quick check. If I tell you the number negative 4/5, what is the negative reciprocal of negative 4/5? All right. Did you say 5/4? I hope so, because you're exactly right. Example 1. Line PQ contains points P, 0, 3, and Q, -2, 5. Line RS contains points R, 0, -7, and S, 3, -10. Are the lines parallel, perpendicular, or neither? Show your work to support your answer. The first thing we're going to do is find the slope of line PQ. That involves labeling our points. I'm going to start with P being x1, y1. Q is x2, y2. I'm going to come over here and label R as an x1, y1. I'm going to label S as x2, y2. You have a much better chance of getting this correct if you label your points. Remember, the slope is the change in y over the change in x. So when we go to write this out, make sure you're putting your y values in the numerator. The first y value we have is 3, so we're going to write 3 minus the second y value is 5. In the denominator, we're going to plug in our x values. So you have 0 minus -2. Now we need to simplify this. 3 minus 5, -2. Divided by, when you have minus a negative, that would change to plus. So we get divided by +2. And then -2 divided by 2 is a +1. I would like you to pause, show your work for the slope of RS, and then turn it back on and make sure you have it correct. Hopefully you filled in -7 minus -10, divided by 0 minus 3. In the numerator, you get 3 divided by -3 in the denominator, which also gives you -1. It looks like I left out my negative sign over here in the first one. I think I said -2 divided by 2 is -1, but I left it off. Now, the question was, are these parallel or perpendicular or neither? Well, judging by the slopes that they're both equal to -1, then that means that the lines must be parallel. So write your answer in a sentence at the bottom there. All right, I wrote the lines are parallel because the slopes are equal. Now, I want to do one other quick check just by graphing these two lines to see what they look like. So you have the point 0, 3. So you're going to go over 0 and up 3. This point right here, we're going to label P. Then we're going to go -2, so to the left 2 and up 5 to get our point Q. Now you're going to draw a line that goes through those 2 points. Next, we're going to graph the point R, which is 0, -7. So I go over 0 and down to -7. I'm going to label that with an R. And then S, I'm going to move to the right 3 and down -10. Label that with an S. Then I want to draw the line that goes through those 2 points. Now, my lines are not perfect here, but I think that's enough to show that they are parallel, to sort of confirm our work that we did algebraically. Visually, they do look like they're parallel, and we know they have the same slope, so they must be parallel. Example 2. It says state the slope of a line. first thing I want to do is decide if this is a positive or negative slope. This is going downhill as I move from left to right, so it's going to have a negative slope. Now let's count the slope. I'm going to start at the lower point. I'm going to go up 1, 2, 3, 4 spaces. I'm going to move to the left 2. That's where that negative comes in. So there's our 4 over negative 2. And then I'm going to simplify that to negative 2 over 1. So if you look here, you're going to also move up 2 to the right 1. Up 2 to the right 1. So you're still on that same line. For part B, it asks you to graph the point 3, negative 4, and plot 3 more points on a line that is parallel to the given line. So here's the key. Parallel, that means they're going to have the same slope of negative 2 over 1. So let's see what this is going to look like. Let's go to the point 3, negative 4. The point 3, negative 4 gets us to a starting point right here. Now I need to graph the slope of negative 2 over 1. From our previous counting of slope, I know I need to go up 1 and up 2 and to the left 1. I need to go up 2 to the left 1, up 2 to the left 1, and that just keeps going until I run out of space on the graph, and then I can just draw the line through here. They definitely look parallel. So I need to just get the coordinates of some of these points. This is one I started with, so I'm going to move to this one right here. To name that point, I want to go back to the origin, and I need to move to the right 2 and down 2. So that's going to be the point 2, negative 2. The next point on the graph is right here. So that would be from the origin. I would move to the right 1 and up 0. So that's the point 1, 0. And then this next point right here is on the y-axis, moving up 2 spaces. So that would be the point 0, 2. You could also have this point right here, which would be negative 1 and up 4. So notice the pattern here for your y values. Negative 2, 0, 2, and 4. You're increasing each time by 2. And your x values are decreasing by 1. 2, 1, 0, and negative 1. Example 3. State the slope of the line. Notice it is going downhill, so I should have a negative slope. We're going to start at the lower point and count our rise. Let's see, 1, 2, 3, 4. And then to the left, 1, 2, 3, 4, 5. So there's our negative. Rise over run, so we have 4 over 5. The slope of the perpendicular line. Remember, the slope of the perpendicular line is the negative reciprocal. So what's the negative reciprocal of negative 4/5? 5 over 4. Part B. Graph a line perpendicular to the given line through the point 0, 3. All right, so the first thing I'm going to do is I'm going to erase my counting of the slope over here. And we're going to start by graphing the point 0, 3. So it has to go through, your new line is going to go through this point. So that's my starting point. And then I just need to count a slope of 5 over 4. So I'm going to go up 5 spaces. 1, 2, 3, 4, 5. I'm off the graph. Just have to make do with the best we can here. And over to the right 4 spaces. All right, so that should be right here at this point. All right, now, what's the opposite of rising 5 and going to the right 4? Well, that's going down 5. 1, 2, 3, 4, 5, and to the left 4. 1, 2, 3, 4. Now notice that when I do that and I connect these lines right here, this should look like it makes a perfect 90-degree angle. You can even take your corner of a paper and stick it in there and make sure that is a 90-degree angle. Now we need to state these 2 points right here. Let's first look at this point right here. To get this point, we're going to go back to the origin. We move over 4 spaces, and then we move up to here is going to be 6, and then we had to move 2 more to get up to 8. So the coordinate here is going to be 4, 8. We also need the value of this point right here. So I go back to the origin. I go left 1, 2, 3, 4, and down 2. So the coordinates here are going to be -4, -2. Louis is looking a little tired. He had quite a long walk with my husband this morning out on Dick Woods, and he's looking for the sun, and he's about ready to go to sleep. I would like to do that too, but it's too much to do. We got to learn some more math here. All right, what's up next? Let's see. For the following examples, these are just some practice problems. These are very much like the last 2 examples that I gave you. So I'd like you to pause your video and actually try to do these without me helping you. And then what you can do is turn back on your video and check your work. All right, don't cheat. Make sure you're trying these on your own. All right, I'm just going to go through it really quick. You started at this point right here, and then you're going to count up 1, 2 spaces and to the right 1. So that's 2 over 1, which would simplify to 2. Notice you're going uphill. When it looks like you're going uphill, your slope is positive. So the perpendicular line, you're going to flip it, and since it's positive, you're going to make it negative. So you get -1/2. All right, the red line in number 2. I would start right here at this point. You're going to go up 1, 2, 3, and over 1, 2, 3, 4. So I actually have the wrong answer here. So I need to correct that. And let's see. This should be, bless you, Seth. We're going to just get this all fixed here. That was rise 3 and run 4. So the perpendicular line is -4 over 3. And then our equation, our slope is -4/3, so y equals 4/3 x, and the y-intercept is -5. All right, for the last one, the line is going downhill, so make sure you have a negative for your slope. When I count the slope, I'm going up 2 and to the left 1, 2, 3, 4, 5. All right, so that is -2/5. For the perpendicular line, you're going to flip it and change it to the opposite sign. For our last check-in, these are going to be the questions at the end of your Ed Puzzle video. What I would like you to do is show your work on a separate piece of paper. Number 1, find the slope of the line passing through the points A equals -2, 3, and B equals 2, 6. All right, so show how you set up with the change in y over the change in x. Find the slope of that line. For number 2, you're going to do the same thing, except we're going to find it for C equals -1, 0, and D equals 3, 3. So for number 2, find the change in y over the change in x. Number 3, based on your answer, are the lines parallel or perpendicular? Or is it possible they're neither? That wraps up this lesson. This also wraps up our first unit. So the next class we will be reviewing, and then you're going to have a quiz the day after that. Please make sure you check in with us whenever you have questions. Email us anytime. All right, have a wonderful afternoon. Bye.